Hi, I'm Brianna Hansen, and for my CNIT 176 computer architecture final project, I turned my Raspberry Pi into a security camera with cloud storage. So, what's the purpose and relevance of my project? So, almost every homeowner these days has some sort of security system, and the demand for these systems will only continue to grow. And according to a 2024 article from Angie, the average cost of installing a security camera is over $1,000. So making your own cloud-based security camera with a Raspberry Pi is much more cost efficient, and it will give you hands-on experience with very important computer architecture concepts that we learned in class, such as networking, operating systems, and file storage. And in addition, cloud storage is much safer than just having the videos saved to the physical device. So with cloud storage, if it gets lost or it gets broken, you still have access to your video history. But overall, homeowners are always going to want some sort of security system. And this, as the world just gets more and more dangerous with more cyber threats, it's important that people know that this is an option. And this project overall has helped me build technical skills, troubleshooting skills, along with problem-solving skills that I can use in future IT and cybersecurity roles and courses. So next, I'm going to be talking about my Raspberry Pi architecture. So I used several of the concepts we talked about in class, such as operating systems and file systems, CPU and memory, networking, input and output peripherals, and Boolean logic. So I used several input and output peripherals in my project. The most important one was the USB camera that I connected to my Raspberry Pi to capture the video. So I had an eMeet external camera that I would just plug into my Pi to set up this camera, security camera. And during the setup, I also used peripherals like keyboard, mouse, and monitor to interact with the Pi directly before setting up remote access. And once configured, the camera would act as an input device, and I could view the video output through the MotionEye web interface. And then the operating system, that's the foundation of my whole project basically. So I updated the Raspberry Pi operating system to begin with, and then I would start to work with that Linux-based file system. And I created a lot of directories for saving video footage, and I had to adjust permissions so that the MotionEye could access and write to them. And I had to connect cloud storage to automatically upload video files. So these steps really helped me understand that relationship between the operating system, file systems, and just how the application in general depends on them. Next, networking. Networking was essential for this project. I had to connect my Raspberry Pi to the Wi-Fi so that I could access the MotionEye interface from other devices. So if I, would go to one monitor and the Wi-Fi wasn't working, I just had to move to another because it's really essential for my security camera to work. And once it was online, I configured it to upload video files directly to the cloud, which also taught me kind of how that client server networking works. So the Pi is basically the client, and it's sending that data to a cloud-based server, like Google Drive in this case. Next, the Raspberry Pi CPU and memory were put to use constantly in this project. So the CPU processed real-time video and handled motion detection through MotionEye, and the RAM was used to buffer video files before uploading them to the cloud. So I noticed that if too many services were running at once, the Pi would slow down a lot and overheat. So kind of that taught me a lot about how system resources, they have limits and how to manage those limits. Yeah. And then lastly, motion detection in my camera was based on Boolean logic. So the software was basically making a decision, a yes or no decision, saying like, did any motion occur or not? And then based on that logic, it kind of starts recording. It would either start recording or it would just stay idle. And then this was a great, I think, real world application of the logic gates and decision making processes that we had learned towards the end of this class. Next, I'm going to talk a little bit about the procedures that I had to do for my project. So, to create my project, I first installed the Raspberry Pi. Well, I had to update, I should say, my Raspberry Pi operating system. And then I had to install MotionEye. That's the software that lets the Raspberry Pi act like a security camera. And I initially faced a lot of challenges with setting that up because at first I didn't have my external camera. So I just was trying to work on getting that software installed, but it would tell me that like certain directories that it needed didn't exist. And so I just got like a bunch of errors and I would have to create a directory and then I would get another error saying, oh, like this needs a certain permission. And so then I have to grant permission. And then once I would fix one error, I get another. So about another directory. So a lot of just creating directories and managing like permissions. But after I finally got that MotionEye um installed, I connected my camera finally once I got it, and I was able to add that to the MotionEye user interface. I was able to add that camera as a device and finally um use that camera and like allow it to kind of detect the motion. Um, so I connected my camera and tested the video feed and it worked. So after that, I installed a tool called rclone, which basically lets you sync files to the cloud storage. So I used Google Cloud or Google Drive, excuse me. And then I linked my Google Drive account and set up my folder on my Pi where the MotionEye starts recordings. And finally, I tested it to make sure that the video files were saved locally and it was also updating to my Google Drive automatically. And then I'm going to move on to my results. So in this video, I'm basically showing you the final results of my project, and you can see me running through kind of that rclone um, commands and connecting my Raspberry Pi to the Google Drive. And so, yeah, those are all my files within that folder. And so here you can see there's my MotionEye folder, and that's the video that was saved within it. And then this page is just showing like rclone was successfully installed. And here is my Google Drive. And so on my Pi, I made a folder within for my Google Drive, and um, I just put that video file from my MotionEye folder to automatically save into this folder. So, um, yeah, so finally I just switch over to the Google Drive and you can see that same video file that's in my MotionEye folder is there as well. So this is just kind of proving that the cloud upload works. And even if something happens to the physical device, the video storage is safely stored online. And yeah, so there it is detecting the motion when I walk in front of it. And lastly, or second to last, I'm going to talk about troubleshooting. So I ran into a few issues while working with my project. At first, the Pi didn't detect my USB camera, but I fixed it by switching USB ports. And I also had some file permission errors when MotionEye tried to write video files. I solved this by changing folder permissions in the terminal. And then setting up rclone with Google Drive was a little tricky at first, but after redoing the authentication, it worked. And then I also learned that I had to restart the Motion service anytime I made changes or they wouldn't take effect. So, throughout this project, I learned a lot about how a Linux-based operating system works. I got hands-on practice installing software using the terminal and navigating file systems. So, setting up ArcClone also helped me understand how to securely connect devices to cloud services. And most of all, I learned how to troubleshoot issues like fixing permission errors and dealing with the camera detection problems. So, these will definitely help me in future IT and cybersecurity courses. Thank you so much.